Well, hello and welcome to this show. If you stumbled upon it, you're probably having trouble with RAIDs under Linux. Now, I don't know anything about Linux, Arch Linux, or any of the others, or really when it gets down to it, don't know anything about Red Hat, Unix, that kind of thing anymore. Just been playing with this Linux Mint, the Cinnamon desktop build version. It's kind of okay, but I've crashed it a bunch of times and had to rebuild it a bunch of times. And when I first got this little system to work with a RAID, it took me a week of some very long days because, there's 6 terabytes of RAID here. Of course, we lose one to the recovery aspect, the parity aspect of it. So you only get 4 out of it. And then there's some file systems, so it's a little less than 4, but it still takes a long time to prepare that much on the drives. And we'll open this up and look at this. I've got some stuff set up. We've got our terminal open. I've already done my logging in as root, which is sudo. If you're new to this Linux and you're a little bit dyslexic, is it sudo or sudo? Just remember it like this: super user do this. And I logged in as a super user and it asked me for my password. Now I'm logged in as root. It tells me right there that I am at root. And so hopefully I don't have that much to do. Here are my notes that built up over a week. And like I said, I don't think I'm an idiot, but I would follow the instructions. I would go out, Google would return results from like web schools or W3 schools, whatever it is, different places, GitHubs and information, YouTubes, and I would follow what it said and it wouldn't work. It would break when I went through the entire process and giving it 3 hours to finish building the array. Everything would look good until I'd restart and it wouldn't work. Sometimes it'd give me the black screen of death. A lot of times it'd give me my 2 green Linux Mint roundy things going around and around and around like that. And eventually it would come up and things would be not where I put them. And we have zombies and whatever. And it took several days before I finally figured out how to at least get the RAID to stay. And then you have to be careful you don't have zombies, as we might have right here. When I went from the Windows storage spaces, you will go into the process, and when you start to build the array with MD-ADM, it will tell you, oh, I'm going to wipe this out. It appears to be a data drive. If we proceed, we're going to wipe out the partitions. Well, it doesn't. It acts like it, but it doesn't. Not with NVMe's and possibly with, this secure boot. You might want to turn secure boot off for this to work. Maybe that's causing some of the complications that we are enjoying today. So anyway, we've got a terminal stretched out. We're going to go look at it, see if we have any zombies left on our system. We have our little page here. Let me pull it up to the top, bring you into it. Here it is. The first couple of lines up here are just a reminder to me and you. Hopefully you'll be able to read this clearly. I'm hoping that that'll be the case. It says, I highly suggest that you have your data backed up. Pretty well much what all that says. It's one less thing because, like I said, it broke multiple times and just didn't do what it was looking for. I didn't find anything on NVMe's. I could find stuff on SDs, SDAs, Bs, and Cs, or I call them spinny disks. I don't have spinny disk in this particular machine yet, but that's what we've got now. I make a note here. I'm telling you on the next line that, hey, I found them under NVMe's and we had to identify them. We get all the way down to whether or not we need to zero out a hard drive. And this was what I found was my secret sauce. I didn't get an array to stay until I zeroed it. In fact, it would build like it was going to be. I could even put a file in it on the file system, but then when I went to restart, it would revert. And you tell me how it does this. It would revert back to having 2 partitions as the Windows platform would have, including the Windows file system flag set. So I don't know what it was doing, but it wasn't doing what it was supposed to be doing. But when I did this, let me bring it up, make this a little bit bigger so we can see it. If you were to come up here and paste my little command, what I've got is we're using disk defiler. I don't know what DD stands for. Maybe disk destructor, disk divider, disk, I don't know, disk displayer, but it's the format we use when we did the cloning of the Linux drive, we use the same thing, and it says take IF, the input file. We're going to run the disk defiler, and I'm going to run the input file is dev0, the word 0, because we're going to fill it with zeros. The output file is going to be dev, and then I would put my NVMe here, or if I had SD A, B's, or C's, or whatever, I'd put my SD there. And then you can do 4 megabytes. I used 500, use huge block sizes. I'm not going to write the whole disk. I could. When I got it to work, I wrote the entire disk, but I think that burns up too many of my terabytes written. So I just wrote through the 200 gigabytes to just wipe out that format. We're not going to run this command, I don't think, because we don't know which ones we're going to be writing over. So we need to do this next command here that's called list block. See right there, lsblk. We're going to list our block devices. So lsblk, just like that. And let me stretch this on down a little bit, give us a little better view. I still give myself a little room there for my little head to pop up. But what I see is, I'm looking at this SDA. This, I believe, is my little card reader. Okay, it's my little SD card reader, like for the cameras or whatever. It's SDA. It's not a spinning disc, obviously, but I think about it, a standard disc, and it's not mounted. See, it's got no mount point because I don't have a card in there. But that's it. And this ROM, this SR0, well, that's my DVD burner. And then we're not running out. And then NVMe5N1 with its partition 1, 2, and 3. That's what those are standing for. Partition 1, 2, and 3. Those are set up. That's my boot drive that I'm running Linux on. Now, if I come down to the bottom, NVMe01, partition 1, 2, 3, and 4, because there are 4 partitions, I'm pretty darn sure that's my Windows 11 drive. And you can see it says it has a 3.6 terabyte total capacity. That's on the drive. I have almost 3 terabytes here in the D drive, and the others are associated with Windows, the Windows setup. Now on the next one above it, that 931, well, that's a 1 terabyte drive. That happens to be the drive that I'm running the Windows 10 on. So that means these that have this zombie RAID 5, it may be type 5, but I've told it to delete it. This should not exist. It says that it thinks it's part of a 3.6 terabyte RAID system. I've gone through and told it to stop MDADM service, and I told it to remove that drive, and it's not gone. It's still sitting there. And at no point have I ever named the logical device MD127. This is some of that weird crap that's going on in this Linux file system. Now, when we look at it, we'll notice what we have: NVMe 2, 3, and 4. And I have a little card here that I will show you. I'm going to bring this up. The 2, 3, and 4, because I certainly don't want to do a bonehead move and wipe out, one of my operating systems. So I know that 2, 3, and 4 is where I have my 1.8 terabyte 770 SN770s. I just want to make sure I identify them properly. Now, if we go back to our little screen here, we can wipe these out and do some block overs for the first little bit, which should fix it. Now, I have some stuff I think I can try to kill off the zombie, but this at the tail end of the sheet that we've got pulled up here to look at, this thing right here. But I want to tell you the trouble that I had taking a full week to get this to work. I don't know if I mentioned this. If I do, I'll repeat it. When I came off of Microsoft Storage Spaces, the drives had been used, and I would look at it and it would say, okay, all you need to do is run the building of the array because it's going to write over your partition. In fact, it tells you that. But it wouldn't do it, and when I'd restart after I had the black screen of death and it didn't want to boot, or I got it to mount, but it would move it to a different location, any of these other weird things that were going on, it even would revert back to the partitions of the Microsoft, complete with Microsoft flags for MSF or whatever it is, Microsoft file system that would show up when I looked at gparted. I don't know why it wouldn't kill it off. So I looked and came up with some information from some site somewhere at some point. As down at the bottom. As you can see on the right, it still thinks it has a RAID 5 on device 127, and I want to break that. So to do that, it first says, well, we can use this down at the bottom, MDADM examine. All right, we're going to copy this, put it over here. All right, we want to look at the multi-disk administrator, see what we've got. All right, it says there are no devices there, but you see it right here, do you not? Disk, this is part of a RAID. So, and it says it is on MD127. I'm seeing it in the block devices, although ADM says it doesn't exist. All right, so we can skip down here. I'm not going to unmount it because it's not mounted. And I'm going to come down here and we can do the file system table. I know it's not there. I've already been in that. So we're going to try this down here where it says to, right there, device. Let's copy that. We're going to remove it because it shouldn't be running. We might want to stop it first. Let's go ahead and stop it first. And it's going to tell us it's not running. But we're going to go down here and grab this MDADM, copy this, and it's just double tick stop, and we have to give it the device. But since I didn't name it 127, I have to look at, obviously, FS block, the file system block of the block devices, the list block devices, rather, and we're just going to do MD127 because you see it right there on the RAID. MD127. Stopped. So it must have thought it was going. So now we're going to come down here and we're going to remove it. And again, it will be 127, not 0. Says no such directory. Again, let's go back and look at it. Let's 0. We're going to try one more thing. And we're going to, now this will be probably what will work, if at all. We're going to 0 the super block, except we have to use the ones that we use, which were 2, 3, and 4 in this case on this build, because they do move, and we will check our card to make sure we actually get 2, 3, and 4, and we can see 2, 3, and 4 up here, 2, 3, and 4. So we've got the right ones. We're going to wipe out the super block. All right, didn't give us any error. And we're going to go and wipe, say, 50 gigabytes on each one of these drives to try to make sure that we are back to being somewhat virginal status before we build our array, because it's going to take 3 hours, obviously, to complete without even putting any data on. We just want to see it if we can restart it and it will remount. So we have this little thing I have up here. There's my create. That's not it. It is this version right here that you see before you. If you can read the file, we're going to use the disk defiler, disk destructor, disk destroyer, whatever you want to call it. And it's in the form of DD. This is what we use to clone the hard drive when we backed it, when we move things around. IF is input file, dev 0, because they're going to write zeros. OF is the output file. Dev, your file, your drive here. And what I'm going to do is I'm going to, because I'm looking at NVMe 2 in 1. All right, that's the first one, 2, 3, and 4. I can go ahead and let that be 4 megabytes, or let's go ahead and make that into 500 megabytes. And we're going to do huge block writes. We're not going to write the whole drive. We're just going to try to blow over the system that's there, the first part of the NVMe, to make sure there's nothing, showing up there. So, all right, so we're going to go ahead and do this. And when we get anywhere from 50 to 200, gigabytes, missing one. Okay, what did I skip on the unrecognized operand block site? Oh, I don't have my 0 there, do I? I messed up. I must have stepped over my equal sign. I need an equal right there. That should get her. And that's a big block write. But like I say, we're just writing zeros. All right, now as you can see this running, it's giving our progress out of the total about 19 gigabytes. What I'll probably do is run this 50. We may even restart the machine to see if we zombie, or we may just go forward from there. We will see you after we wipe out the other 2 drives. Now, this ought to do it. What did we do? We stopped the MD ADM, which it says it wasn't running, but it still stopped. We still got a logical device on 127 that I didn't name it there, and we do have it labeled as RAID 5. This is some modification Linux did when it started. Now it's still there. We should be able to get a build on our hard drives, but I think there's something a little bit different about NVMe's. I tell you what, we're at 78 gigabytes, 80 gigabytes. We'll just let them run. We'll do it. We'll split the difference between 50 and 200, and we'll cut them off at 100. Now this should wipe out the lower memories. We've already killed off the super blocks, so they shouldn't be there. This RAID should not exist. Let's go back to our circle cam here, and you see we're already at 105, so I'm going to do a Control-C. Control-C again in case that didn't take. Wait for it to give my command prompt back to me. There we go. We're going to back up that same command one time, and we're going to change 2 to 3. Go to the end. We're going to let it run 100. Then when you're not watching, I'm going to go ahead and do 4 as well, because that's my other drive, right? 2, 3, and 4. We'll see you in about 5-10 minutes. Well, we've got the first 100 gigabytes of each of those 3 drives written over there in all zeros. Let's just have a real quick review of trying to erase this, and it'll give you another opportunity to take a screenshot. Maybe you can see it, maybe you can't. We'll see it down here at the bottom. All right, it says to remove an array if you need to, assumes it loaded successfully. I used the name SSA instead of something else. I thought it would. I discovered that some of the early videos and things I found used MD0 for both the logical device. What we just saw was 127. I didn't name it that. And we have the directory that gets created. I called it SSA because it would not mount. It had all kind of strange weirdness going on when I called them the same thing as was sampled out. But what did we do? We checked it. It didn't show that there was a drive alive. We didn't need to unmount it because it wasn't mounted. We went into the stop mode. We stopped MDADM, and then we looked at this down here right below that. We removed it. We zeroed the super block, and we now just blew over the lower half. So now we should be, or the lower 100 gigabytes of each of those drives. Now we're going to go back to our system here, and we're going to bring up LSBLK. We're going to see if it did anything or if we still got our zombies. Right, look at that. We have 3 beautiful NVMe's, no logical devices, and we have absolutely at this point in time no mounts, no file system, no array. We should be good to go to build a successful array this time. Good deal. I'm feeling quite chuffed. So now we just go back up to our file, and we've got to do the array building part where we're right down here. We have this little command that I have available. It's MDADM. I guess that stands for multi-disk. Let me go ahead and clear this off. All right, start where we can see on a fresh screen. We're going to go ahead and paste our command. And if you look at it, you can see the actual command is MD, multiple device or multiple disk. I'm not sure what it is. ADM admin, double tack create, because we're going to make an array. Double tack verbose, because we might want to see some information. The /dev, which is one of the roots off of, or one of the directories off of the root. Dev MD0, we're going to call it multiple disk 0 double tack level equals 5, because we're doing a RAID 5. Now remember, your RAIDs We have a couple of different, basically the only ones you need to really remember are 0, 1, 10, and 5. 0 is easy to remember. That's just striping. It improves your performance, does 0 data protection for your drive failure. 0 data protection for drive failure. That's MD0. MD1, you'll get 1 terabyte for every 2 terabytes of drives that you have, and they have to be the same size because they're mirroring, you know, 2 1 terabyte drives will give you 1 terabyte, but it's making a mirror of it. And 10 is a mirror and a stripe system together. You have a stripe set and a mirrored set, and that takes 4 drives. I don't have 4 drives. I got 3 drives. So I'm doing the RAID 5. I don't know why they call it 5, but it's 5. The minimum you have is 3, and what it does is you have 1 parity drive extra than your list. So if I had, say, 10 1 terabyte drives, I would have 9 terabytes of data and 1 for, you know, the redundancy, for the error correction, for the rebuilding, 1 spare, whatever you want to call it. I have 3, so they're each 2 terabytes, technically 1 at 1.8 when they're done being, you know, what, formatted or whatever. So I've got effectively about 6 terabytes of drive, but I get 4 terabytes of usage in the 2 drives. So that's not too bad. You're only losing a third of your drives instead of, like with a mirror, you lose 100%. You got 100% in the size and then 100% lost in the mirror. So that's what that is. Let's go back to my circle cam, and that's the RAID devices equals 3. You got to get all your 3 there. This one from the file, this time I had 1, 2, and 3, and we don't have 1, 2, and 3. We have 2, not 21 N1. We have 3 N1. NVMe, I stepped on the wrong part, and NVMe 3 was 4. So these are 3 devices. And once again, because I don't want to be embarrassed on camera, there's my card with 2, 3, and 4 on there. This is what takes 3 hours to build this up to its complete form. There we go. We see what it says. It says that it has been started. It's telling us it's not MD127 like we saw ghosting us a while ago, zombieing us a while ago. It's now MD0 like we named it. Now we have another thing on this side. If we go past that, what we're looking for is this next little command. It says you can check the kernel to see if the RAID now shows up. If it's working on it, we're going to do a copy. And cat, if you're not a Linux guy, is from concatenate, which means just kind of like you put a string together. It really is almost like an echo to the screen. It's going to go look at our file in the proc. Proc is associated with the kernel, and we're looking at MD, the multiple disk, and this is the status. It's a little text file, and we're going to look to see if, in fact, it shows up. And praise be, there it is, MD0. Notice it's not MD127 like it was a while ago. I have no idea where it's coming from. It's telling us it's a RAID 5 using MDE or NVMe 4, 3, and 2, just like we told it to. That's good. All of that's good. It's writing some of the blocks. And we're come down here, we're at 0.6%. And we expect to be finished in 160 minutes, so to speak, at the speed we're going. All right, it's going to take a while. And we see this little, if you're not done this yet, you see that little arrow, the little greater than. We're going to zip across more and more like a progress bar, but this is text, it's not graphics. So it'll just kind of march it across, and we can check at it from time to time as we do some more stuff by just using the same command, cat, cat like meow, cat space proc, that's a subdirectory there, and mdstats, the actual file. If you like this content, please go to calldeltosell.com, find the tab that says on YouTube, click it, and it'll open up a page of QR codes. There you can use a smartphone to scan and get to the YouTube page, or you can just mouse over and click it on a PC. There you'll be able to subscribe to this little button over here and click the notification bell. Now what we want to do is we're going to go back to our little cheat sheet that I built up, and what we want to do is do the make a file system, and hopefully, let's see if it does it. Let's see if it does it. If we successfully wiped everything out, including the first 100 gigabytes of each drive and the stuff you saw we did, we killed it and all that, and zeroed the blocks out, the super blocks, I have done this after that, and I tell it to make a file system, and it still comes back and says, there's a file system already on here. This Linux is strange. It is strange, and I don't know why, but we're going to go ahead and put it over here. I'll go ahead and put you back on screen where you can see it. All right, let's do the little square one that's on the rectangle side. And remember, we called it MD0, so everything is fine. We're going to make a file system, MKFS, make a file system dot, and we're going to format it to ext4. Yeah, you could probably do NTFS from what other people say on the internet, but I'm not going to try that. It's not native to Linux. I just want to go ahead and do it Linux way, and then file share just a few directories I need to, and that's it. Now we're going to mount it in a different location, but we're going to go ahead and make up this file system right here. And you see what it did? It did create our super blocks that we had previously deleted. So I'm super happy about that. And it says that writing the super blocks and file system accounting information done. I don't see any errors there. So again, praise be. Next thing, we want to go over here to this. And I want to change where we're going to make our mounting directory. And this is really strange, because let me tell you a little story here before I do it. The standard way, looking at like web schools and all the other stuff, they would put it in the mount directory, subdirectory off the root called mount, MNT, where they normally would mount more permanent stuff. I did that after I finally got the RAID, the array to survive. I did that, and it black screened Linux. It broke. And then there were a few times when it would do the green spinny balls, because I have my two monitors. You can probably see me looking up. It's tough on my neck, but I got to do that because I don't have desk space. And it would do that and take a long time. I don't know what it was working out, sorting out. Sometimes it would fail and even revert back to those previous partitions. Weird, totally weird. Don't know about that. When I finally got past that black screen of death, by the way, we're going to look at this thing called the file system table, FS tab. Doesn't have an extension. If you were to black screen and you see that where it gives you the opportunity with the Linux Mint, and it says, hey, do a Control D. Do your Control D and zero down with your character turn until it stops somewhere. And then you can do your nano /etc fstab and go delete that line that we're going to put in that's going to have the UUID in it, so that you can just rip that line out, save the file, and reboot and see if you don't come up normal. And that will maybe take a few years back off your heart that you just had, because you just broke your system trying to put a RAID in. All right, so let's go back down to the two screens. We're going to change this directory. I am going to keep my convention of calling it the solid state array, but I'm going to take it off of mount and put it into my home directory in Dell that's off of media. And if you're not familiar with where that is, can I show you that? Are you still not turned off? Are you interested in this enough to keep watching? All right, well, here I am. This is my user. I'm in Dell right there, as you see. Well, if I go back until I have this thing that looks like a dot or a Q, kind of a dyslexic Q in a rectangle, that's supposed to be a disk drive. So that takes us back, all the way back to the back, to the file system. And you see we have etc, we talk about that. Bin is the binaries go there. Libraries, the proc for the processes, router here, system. You see we got a number of things. There is our mount directory that a lot of people would use. So I'm going to go to home, right? And there's my Dell, and see it put a cute little icon of a house on there. And I'm going to go there, and this is where I want to go ahead and put in my media, somewhere in my media. Let me back up one. Let me go find my media. If I didn't go too far, where's my media? There it is. So it's off of the root. So I have the file system, base file system, and media, right, is where I'm going to put it. I could put it off of home and Dell, and it will probably locate it there when it reassigns it. But I'm just going to go ahead and type in media. Like I say, I could mount one of these other drives and show you where they are. Let's do that just for kicks and giggles. All right, here I'm going to mount this data drive here. Mount it. Now let's see, you see this thing that looks like a mini ball, the little muzzle loader bullet shaped thing. Let's see where it is. It's under Media and Del. Okay, right off through Media and Del, it comes off the, look, I could tell this thing to mount it off of Media and Del. We might do that. Let's try that so we can get a clean appearing mount. Media, and I'm just going to go ahead and put it off my user. This may be a mistake. Del, I'm going to put it off of Media and Del. This is make the directory. If I need to, it can do the parent before the child. Media does exist. Del does exist. We just need to make the SSA or my solid state array file directory. Hit that. Now that's made. The next thing we're probably going to do is mount it. Yes, we're going to come right down here. We're going to grab this, copy this command, put it over here. But remember, we are device 0, not 127, but we're going to change this from mount to media/del. That's my user. And we're going to keep that same file name, SSA. Hopefully it will tell us it mounted. Didn't give us any error, so it did in fact mount. And you will notice what magically appeared right over here when you weren't looking is this looks like a dehydrator. It's supposed to be like a DAS or something like that, or a detached storage unit. And if we pull it up, we should have our mini ball. See, we were mounted. If you're not familiar with Linux Mint, we're mounted. There it is. So we've got it mounted. It mounted successfully. Now what we want to do is we want to go start looking at the temporary file system. This is what's running in memory. We're going to grab this, DF, and I have some notes above you. You can do DF or DU, whatever you want. We're going to use this. The H is for human, and of course temporary file system. So this tells me I think this is in the memory itself. So this is in RAM. Right, because we see RAM here in just a minute. We hit that. If I get in the right spot into terminal, it did load it up. There I still see my lovely DEV MD0 3.6 terabytes. We're not using much of it. 28K so far of 3.4 usable 1%. It's saying it's mounted in Media Del SSA, and that just kind of puts. Normally, let me tell you this. If I didn't say it, I'm going to repeat it. If I did say it, it's repeat. Normally mounts are for stuff that you would load up after the fact, manually load up. The media, especially media off of a user, that's something that while they're logged in and they're the active person, maybe put a jump drive in there, a USB drive, something like that. That's going to pop up. You mount a camera or something to a USB, that shows up. Normally those go into media. I'm just going to go ahead and associate it with my personal user because I'm the only one that works on this machine. So that's what that's about. That's why I'm going to try that, see if it works. Back on our circle cam, we've got it mounted. It did. We see that we have on 0, we have on 5 and on 5.3, these are our active partitions, our window. We could unmount that, watch it disappear. I'm going to go over to the side here, bring this up, and watch this one, this Windows Pro disappear when I unmount it. See it popped up, it's unmounted. So we're not blowing anything up. Now if we come back up and we do the same temporary file system, you'll notice that the 705 has been unmounted, so it's not there. This is different than Windows. So if you're a noob like me, this may help you. I know I'm running a long time and I hate doing long videos. I swear I hate doing long videos. But here we go. Now we've got to get this into memory. This next command that we have down here, we're going to scan. We're going to pipe something, and I'll tell you about a pipe, which is probably more information than you care about unless you've been frustrated working on your computer trying to get your RAID going and you're just ticked because other information didn't help. I'm going to use this MDADM, and I'm going to do a double tack here on the detail, and I'm going to scan, I guess, the system and tell me what I've got. And now we have our UUID. And the reason I did it this way is because I want to save this. I want to copy this off of my screen. We're still at MD0, so Linux hasn't buggered that out, and I have a space down here to put this. I'm going to tack that right there because we're going to add to a file here in a little bit in the file system. All right, let me slide my little guy back over there. So that works. Now we need to pipe this into the configuration file. And this is this command right here that we just kind of looked at. We looked at half of it. Let's put it up here, paste. It's the MDADM, or whatever the multi-disk or multi-drive, whatever administrator, double tack detail, double tack scan. And that vertical line, if you're not a programmer and you're not a nerd or whatever, you might not realize it, it's that vertical line that sits over close to your right-hand side of your keyboard over your return. That's a pipe character. That's what Python used it for, a pipe. Back in the old days, we have other things. I got some notes on it right there. Sudo, all right, we're already logged in as super user, but we're going to do a T and a T, just like a pipe. We're going to append this file, which is the etc md adm file, the mdadm.confg. It's going to take that text that we're going to pull out of the detail and the scan, and it's going to shove it into the tail end of that file. If you're really curious, we can actually look at that file before we run the command. Do you want to do that? We would just use cat. You just do cat in that etc, this part of the command, and you can see that it's not there. It's also a good idea, if you had a failure of your build when you did an array, to do that, to cat it first, just so you can make sure that there's nothing there. All right, it says it went. Let's go ahead and try that cat to verify it went into our file. And we have our other things. So we're just going to grab the etc, md, that little tail end of that, copy that, put it after our cat. Because trust me, it's faster me doing it this way than me typing. All right, now this is what that file looks like. We just had it come to the screen. And this little line right here, array dev md0, metadata 1, 2, spares 1, UUID, and notice what it's ending in. It's ending in this double A, double D. Is that what we put over here on our file? Yes, it is. So we've got the correct UUID. That's universal identifier. So we made it to the file. The next thing we've got to do, let's go ahead and pull this up to get it better screened in. All right, we have our UUID I pulled in. We want to make it resident in the volatile memory system, so that's this little command here. We shouldn't have to use sudo update. We should just be able to do update because we're logged in as super user, but watch it make me out to look like an idiot. I tell you what, let's clear this off. Let's start so we can see it. All right, let's put her in there. And because we're logged in, we should just be able to hit this. It's show it the RAM file system. There it is. And you see this beautiful line that we got here. This beautiful line right there generating the boot init rd image 6.0, this generic. Over here, you'll see something I've got typed up, and I put it in here. In that week of embarrassment and humiliation, being a noob on this Linux system, I had an error, and it said it couldn't get this resume file, and I didn't know what a resume file was. So I looked it up and I used the command and it fixed it, and no longer did I see these complaints about the init file system will attempt to resume blah blah blah. I just used this command, and if you don't have to use it, I wouldn't use it. Printf, and this is a F string, looks like a resume block ID, and it's got another pipe and yet another pipe after that and another T. I have no idea what that is. Some smart sucker figured that crap out. But when I did it and I told it to do all of them, I said sudo update, give me my updates, do all of them, and it had 3 drives running. So there it did. It generated 3 beautiful little perfect little one-line entries just like we have right here. So I'm feeling cocky. I'm feeling proud of myself. I'm feeling like I could kick the Statue of Liberty into tow and she's screaming holler. I feel like I'm Superman. Fly up to the, okay, got that going. You get the idea. Okay, now we've got to run this next thing here. And what we're going to use on this command is it's another piping. We're going to echo this string. I'm going to put it here because we're going to write to another file. Echo, that's what echo means. Send it back to the screen, and we have a string. When we go into the file, we're not going to have the quote mark because we're telling it to echo this string, and it's mount SSA. I need to change that because where did we put it? We put it at media, right? At the user, the current user, which was Dell, and we did use the SSA. It is formatted ext4. We have defaults of 0 and 0. The first one has to be 0 for some reason. I looked it up. I can't remember why. It's just old and it just has to be there. Legacy. This next 0 can either be 0 or it may be 2. It just tells the system, file system, to check the drive. I think I just leave it at 00 rather than having it 02, just because I'm tired of working on this computer. Sudo T, I really shouldn't have to sudo it at this point in time. We're going to append, that's what the -A is, single tac A, etc fstab, that is our file system table. Make a note of this. If you lock up your boot when something screws up and you have to edit and you get that black screen of death, you want to go into this right off of the root. You'll have to be a super user, you have to be the root, logged in as root, but you want to go into etc fstab. You'll use a nano, that's the editor. You go in there, take out that line that's screwing up your boot, and that should make it mucho betterer. How about that? So we've renamed it to our Media Del SSA. We still have our MD.0. I think we're in good shape. There, we did it. We sent it. Now, like say we screwed this up somehow or it didn't boot right. This is what you'd want to do. You'd want to do a sudo or sudo su if you need to log in as root. If it refuses, if it won't let you save it, you have to do that. You would type your password in. What we're going to do is type in nano, all right, nano space this file, which is etc, right off of the root, and it's fs for file system table, and it has no extension. Hit it, and you see this beautiful file we popped up. You'll notice that there's no red line at the bottom telling you it's in read-only mode, and right there is our beautiful line we just wrote there. But we're here for a reason. Well, I interrupted myself because we're right down to the very last command, and I want to make sure we do it right, and I want to make sure I don't lead you astray, because I might do that. When I was doing this, that took me a week to get this simple thing done. Of course, I was a newbie, so I was struggling to know what the commands were and work on it. And my biggest trouble was the RAID kept breaking. The array itself kept breaking. And when the array kept breaking, it didn't matter. Even if I got it mounted, it didn't make any difference, because when we rebooted, it all disappeared, or it locked up the screen, or it tried to reboot and it had problems. And I think that was related to not being able to clean out the drives. And we've covered that on the first part of the video, but I don't want to lead you astray with one thing. Let's go back to where we were. And I've made a little enhancement in my little sheet, and I apologize, I won't be able to send it to you or whatever. You have to read it off the screen, and hopefully the video will compile clean enough for that. But somewhere up here at the top, I had this first UUID. You watch me, I made a note of it. Well, that was for the array, and I wanted to make sure I'm very clear with that. That's for the array itself, okay? That's for what MDADM uses. That was the one that was breaking on me. It would just something, I don't know what was going on. I don't think they formatted correctly, but that was the one. So I've added this note up here, and I want to make sure you understand that use the correct UUID when mounting the file system or adding it to the etc fs tab. That's what we're getting ready to do. That's where we were when I interrupted myself. You should use the file system UUID and not the MDADM array UID. So that's the one, and I made a point of telling you, okay, it's an AADD. That's the array. That's not the one we want. We want to get this other number, but where do we get it from? Well, that's what we're getting ready to patch into this file. So we go all the way down to the bottom where we were, and I've changed this command for you a little bit so that you don't have to fish it out as much, and it actually presents a little bit better. So what we want to do is we either use this one, or we can use either one of these list blocks. I like list block -F or TAC-F or whatever, but that gives me the whole thing, gives you a little bit more information. I tell you what, let's look at the list block TAC-O and plus, of course, UUID, and let's see what that output looks like. Get my mouse to work right. All right, I like this view because what it's showing me, and I'll go ahead and do the circle cam so I get a little bit bigger, a bigger square down here. But what it shows us is we get both of them together in case we get really forgetful. We know we got the right drives because they're 1.8T, so that tells us they are on the NVMe's themselves, the drives themselves. They are the AADD. You can see that. All right, the next one is the MD0. That's our logical device. That is showing that it's 3.6, which would be our 4 terabyte drive. It's a RAID 5, and you show that it's mounted at Media Del SSA, just like we wanted it to be. And you see it ends in a different number, this 7808. Where do we get that number? Well, we can just snatch it right here because we have it loaded up already. But this gives us, I think, a better vision of the file system. But to not be confusing and to keep it super simple, what I did is I added the DevMD0 on the bottom of my list block so that you get a much cleaner, simpler looking UUID, because this is what we need. We need this, see this DevMD0 UUID. Let's go ahead and grab that part right there. We'll have to remember to trim off the 2 quote marks. I think I'll just go ahead and trim that last one off when I grab it, but we can't forget the one after the equal sign. Now that we have that, we'll go in there and we'll open that file where we just were, right, which was nano etc file system table. There we are. We've got no red line at the bottom, so we're not, you know, in read-only mode. And there is our line that we just piped in. And remember, we said we could have that as 00 or 02. So what we want to do is, I think I'm just going to go ahead and remark that out, because I'm going to copy in just a second. Let me see if I can wrap around. Now this is where I put our UUID we just looked at, remembering to take off our little quote mark, because that will booger it up. And now we can just go up here and grab this next line from the media del at SSA, copy, put that down here. If I can get my little fingers to type, paste. I'm a little painful to watch when I type, right? So there it is. Now I can hit the Control 0. We open it up down here. Remember, it's hard to see, but you can see it right there. Do you want to write it? Yes, we want to write the lines, and then we do X, and we're out. And we should be in a position just to boot and see if we load. And again, like I say, I'm not going to show you the restart. We'll save that for the next video. We're already really long, and I apologize for that. I hope my videos are worth listening to me try to explain some things. Even if I stumble over the words, maybe they will help you understand something that maybe I didn't, and you get a little bit of benefit. Anyway, we're just here to help. I hope you have a great rest of the year, and click like and subscribe if you will. Tell your friends, or recommend this if you found it to be worth the 40 minutes or whatever the video is going to work out to be. Thank you. We'll see you later. Bye.